Good morning, everyone. Today we are going to discuss a topic in our BW basic electrical engineering. That is the most versatile and important part of our electrical engineering branch. So we are going to start now. As you know, the main parts of our electrical engineering is resistor, capacitor, inductor, etc. Like we are going to discuss about what is resistor, what is capacitor, and what is inductor. So, first one, resistor. The symbol of resistor is and the unit of resistance is R. Sorry, ohm. As similar to second we go capacitor. Symbol of capacitor is two plates connected parallel, and its unit is R. Third one, inductor. Symbol of inductor is coil next and its unit is Henry, or we can call it H. It means R and this is ohm. So these are the main parts of our electrical engineering, like resistor, capacitor, and inductor. After this, we will discuss about how it behaves in series connection, how it behaves in parallel connection, about each and every component. So next, we will go the series and parallel combination of every component. At first, we will see how resistor behaves in series and parallel connection and what's its formula. So, in series connection, resistance connected in both ways, like where resistor, more than one resistor connected in series, where like resistor 1, resistor 2, resistor 3 connected in series, we get DC source. DC source. This is resistor 1, this is resistor 2, this is resistor. Got it? So, we will discuss the formula of resistor connected formula for series connection is R equivalent equal to R1 plus R2 plus R3 up to Rn. Rn stands for the number of resistors connected in series. Like in place, we have more than 3 resistors, then more than 3 resistors can add together to get R equivalent or equivalent resistance. So after this, here one more thing, here current constant for every resistor. Okay, and voltage varies. After this, we will discuss parallel connection. In parallel connection, more than one resistor connected in parallel. Resistor 1, resistor to resistor B connected parallelly with a DC source. Here, this is R1, this is R2, this is R2, and this is a DC source where positive, negative terminals are. So, current here defined as here current constant for this resistor, but parallel current here is in no this I and this is I1, this is then I2, this is I3, this is I4. So for parallel connection of resistor, equivalent resistance we have to keep an equivalent resistance or one R into current equal to one current plus one R2 plus one R3 up to one. Here, one thing students see, as in the series connection, we get directly R equivalent equal to R1 plus R2 plus R3. We get the value of R1 directly, but in case of in case of parallel connection, we see that 1 by R equivalent. So we don't have directly, we did not get R equivalent. So how do we find one R equivalent? There R1 R2 into R3 up to Rn. In numerator, we multiply R1 to R2 up to Rn. And in denominator, there is R1 R2 plus R3 up to Rn. So, if we take this equation 1, this equation 2, got it? In series connection, how do you get R equivalent? In series R equivalent to R1 plus R2 plus R3 up to Rn. This is our first question. In parallel case, we got R equivalent to R1 to R2 to R3 up to Rn. Denominator divided by R1 plus R2 plus R3 up to Rn. Got it, students? So now we take some examples by taking some values of this. So here let's take the value of R1, or we are going to someone over. So let a T resistor connected in series with a voltage source DC plus minus in unknown voltage source. Here we take R1, R2, R3. So value of R1 equal to, let's say R4, R2 is equal to 6 or value of R3 equal to 8. So what is the formula for series connection? That is R equal to R1 plus R2 plus R3 up to Rn. So here we have three resistors. So we are going to add R1, R2 plus R2. The value of R1 we get 5. Value of R2 6. Values of R3 8. So by adding this, we get 6 plus 5 plus 8, we get 19 ohm. A simple problem and simple solution as you can see. So now we are going to take another problem. Problem 2. So I am just changing the value or putting the value of R1, R2 and R3. Can put similar value like 5, 6 and 8 which we take for series connection. So value of R1 5 ohm, values of R2 equal to 6 ohm, values of R3 equal to 8 ohm. So we know what the formula for parallel connection? R equivalent equal to R1 into R2 into R3 up to into Rn divided by R1 plus R2 plus R3 up to Rn. So what we get here? We have three resistors. So we multiply R1 into R2 into R3 divided by R1 plus R2 plus R3. So from this, what we got? The value of R1, 5 ohm. The value of R2, 6 ohm. The value of R3, 8 ohm. Divided by 5 plus 6 plus 8 ohm. What do we get? Students, 5 into 6 into 8 into 5 by B, 30 into 8 to 40 ohm divided by 5 into 5 plus 6 plus 8. What do we get? 90 ohm. So 240 by 90. Totally we get what is the R equivalent 240 by 90. If you want to solve or get final values, then you can solve this equation and get equation points also. So after this, we will going to discuss about capacitor series and parallel connection. We got this? Okay. Now we discuss about capacitor. What capacitor did? Capacitor stores energy. And I forgot that what resistor do? Resistor regulate the current in our electrical circuits. So now, as you know, symbol of capacitor is this, and unit of capacitor is Farad, which can be written there. Now we will see series connection of capacitor. You can you already know the resistor how it looks in resistance that the reverse things is applied to capacitor wise. Like in series capacitor, how the formulas are reverse. Like in resistor, the formulas what we apply in parallel case that will be applied in series case of capacitor, and what we apply in series case of resistance that apply in parallel case of capacitor. So we will take how it looks like. See, in capacitor, three capacitor connected in series with a DC source, positive, negative. Here, here in series case, current divided like here flow I, then capacitor, let's say this is C1, C2, C3. Capacitor 1, this is I1, capacitor 2, this is I2, capacitor 3, this is I. So, formula for series connection of capacitor is 1 by C equivalent equal to 1 by C1, 1 by C2, 1 by C3, up to 1 by Cn. So, as similar to resistor, you see that what we have the formula 1 by C equivalent, which is equal to 1 by C1 plus 1 by C2 plus 1 by C3 1 by C1. But we did not get that C equivalent, so we subtract get C equivalent equal to C1 into C2 into C3 up to Cn, and the C1 C2 plus C3 up to Cn. This is the formula for C equals to. So, as similar to series connection, we get parallel connection. In parallel connection, let's take C1, C2, C3. Let's take the value I. Here, current not constant. Current varies. Sorry, current constant. But in series case, current varies each node or for each capacitor. Like current flows I. And for C3, this is R. For C2, I. Outgoes I. I. Now, C equivalent in parallel is C equal to C1, C2 plus C3 up to Cn. So, the equation 2, or you can take whatever you want. Now, we will deal with the problems, or we'll take a problem. Here, I will take some values by considering these problems like here I take the value of C1 is like 3 pi. Value of C2 equal to 4. Value of C3 equal to 5. Okay, got it? So what's the formula we have? C1 into C2 into C2 up to Cn. C1 plus C2 plus C3 up to Cn. So how many capacitors over here? 3 capacitors. So P equivalent we have C1 into C2 into C3 divided by C1 plus C2 plus C3, which is C1. What is the value of C1? What is the value of C2? What is the value of C3? Divided by what is the value of C1? 3 plus 4 plus 5. So now times what the product of 3, 4 and 5? 65 divided by 3 plus 4 plus 5 is 1. 9 plus 3 is equal to 12. Oh, sorry. So what is the value? 60 by 12 is equal to 5. Similarly, we will take different values and different problems for each combination, like series combination of capacitor, series combination of resistance, series combination of parallel combination of resistance, parallel combination of capacitor. For parallel combination, we will take the same value, 3, 4, and 5. P1 equal to 3 farad. C1 equal to 3 farad, C2 equal to 4 farad, C3 equal to 5. So, what we have C equivalent equal to, there is P equal to 1 into plus C3, that is C1 equal to 3 farad, C2 equal to 4 farad, C3 equal to 5. So, 3 plus 4 plus 5, what do we get? 12. Got it, student? As you see, these are not more than a chocolate. So you can solve by seeing the equation and by getting these formulas. And we will apply this formula in different like connection series parallel, like star delta, delta star connection, and different like we get combined circuit. Like we will use these equations in every kind of circuit connection. Like there are some theorems like Newton's theorem, Thevenin theorem, superposition theorem, and different theorems. So today's this month for today we will meet next session.